So earlier we calculated the circular equations. Now when we keep circular equations for Cxc1 plus C2 plus C6 is equal to 0, C1 plus Xc2 plus C3 is equal to 0, and C2 plus Xc3 plus C4 is equal to 0, C3, C4 plus CXC5 plus C6 is equal to 0, 1, 2, 3, this will be XC4 plus C5, and this will be C3, this will be 4, and C4 plus XC5 plus C6 is equal to 0, this is 5, and C1 plus C5 plus XC6 is equal to 0, this is equation number 6, and we put the value x barabar 2, then this will be x barabar 1, this is x is equal to 1, so we get this C1 when we put the x barabar 1, so here, and it is C2 plus C3, and here it is C3, here it is C4, it is C5, and it is C6. So if we subtract 2 from 1, then what we get? If we subtract 2 from 1, then C6 subtract 2 from 1, then we get C6 minus C3 is equal to 0, therefore C6 is equal to C3. This is one relationship. And if we subtract 2 from 3, we get C2 cancel, then we get C4 is equal to C1, and if we subtract from C3 from 4, then we get C4, C3, then we get C5 is equal to C2. This is this relationship we get, and if we keep these values, then C1, C2 in place of C6, then we get C3, because C6 is equal to C3. C1, C2 and C3 is already there. C2 plus C3, C4 is equal to C1 is equal to 0. C3, C4 we can replace C4 by C2 and C4 by C1 and C5 by C2, and C4, C5. C5 is C2, C6 is C3 and C4 is 1, and C1 plus C5 is C2 and C6 is equal to C3. So we get this 6 circular equations in single. We have reduced this 6 circular equations in single C1 plus C2 plus C3. Now we cannot evaluate these coefficients. So for calculating molecular orbital, we can arbitrarily fix any value. We can give any value to this coefficient, and suppose we assume that that value is 0, and we put C1 is equal to 0. But it should follow, if we are putting C1 is equal to 0, So it is necessary that this condition will be applied only when these all orbitals are orthonormal, or they follow the they fulfill the condition of orthonormality, and these all 6 secular equations which we derived, they are also followed by this. And all these 6 equations, 1, 2, 3, 4, 5, 6, they should also be satisfied when we are assuming that C1 is equal to 0. Then we can put values C1 0, C2 is equal to C5, C3 is equal to C6, and C4 is equal to C1. It is C4 barabar C1. C4 equal to C1 is equal to 0. Then we put C1 plus C2 plus C3 is equal to 0, or C1 C6, C1 is 0, and we can write down that C2 plus C3 is equal to 0. Therefore C3 is minus C2. And now we will take all the coefficient in terms of C2. So we got C3 is equal to C2. Now we calculate that C4 is already 0. C1 is already 0. And now C3, C4, C1, C2 and C2 and C5 is equal to, already is in terms of C2, and C6 is equal to C3 and is equal to minus C2. So all the coefficients we have taken in terms of C2 because C1 is 0. So we put this in. Now we get very well calculate for phi 4. This is phi 4. Phi 4 is that C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 F6. So C1 is 0, 0. C2 F2 plus C2 F2. C3 is minus C2. So it will be minus C2 F3. C4 is 0. C5 is again C2 F5 plus C6 again, that is minus C2 F6. So we get that phi 4 is equal to C2 common, we take out common, F2 minus F3 plus F5 minus F6. Now we can evaluate the value of C2. So and applying the normalization condition, normalization condition, that C1 square plus C2 square plus C3 square plus C4 square plus C5 square plus C6 square is equal to 1. So C1 is 0, C2 square is C2 square plus C2 square plus plus C4 square is 0 plus C5 square plus C6 square is equal to 1. Therefore this is C2 and C6 is also C2. Now 4 C2 square is equal to 1. Therefore Ct is equal to 1 by 2. So here phi 4 is 1 by 2 F2 minus F3 plus F5 minus F6. And this is fourth anti-bonding molecular orbital and having no electrons. Okay, now next we calculate for that fifth molecular orbital. Then again this is the case of degeneracy, and phi 4 and for phi 4 and phi 5 x is equal to 1. So this is case of degeneracy. Again we can have that those relationship that C2 is equal to C5, C1 is equal to C4, and that C3 is equal to C6. But now we cannot repeat the value of C1 is equal to 0. So for calculating the coefficients, we will take the condition of orthogonality. Then orthogonality condition is phi 4 and phi 5 d tau should be equal to 0. So phi 4 is C2 F2 minus C3 F3 plus C5 F5 minus C6 F6 multiplied by C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 F6. Now see this, C2 multiplied by C1 orthogonal, C2 square F2. So here we get C2, here it is C2 square, C2 F2. So we get C2 square F2 square d tau, and this is C2 C1 C2 square F2, and C2 C3 orthogonal, C2 C5 orthogonal, C4 orthogonal, C2 C5 orthogonal, and C2 C6 orthogonal. Similarly, if we multiply C3 C1 orthogonal, C3 C2 orthogonal, C3 plus C3 C1 F1 plus C3 orthogonal will be 0, and C2 F2 C3 square and F3 square d tau, and plus sorry, I am revving this because we got that phi 4 was 1 by 2 F2 and F3, and this has the and this is the orthonormal condition, because and just now we have derived equation for phi 4 this is. So multiplied by 2 on both sides, this is equal to 0, and if we multiply it by 2, then it is d tau 1 by 2, and if we multiply this equation by 1 by 2 on the both sides, then it is cancelled. So we get F2 C1 orthogonal, F2, so here will be C2 F2 square d tau plus F2, this is C3 orthonormal, F2 C4 orthonormal, and with other it will be orthonormal. Now we take minus F3. Minus F3 plus orthogonal, F3 F1 orthogonal 0, and F3 F2 orthogonal, F3 F3. So we get C3 F3 square d tau plus other will be orthogonal. F5 will be orthogonal with other orbitals except F5. So here we get plus C5, this is plus C5 and this is, yes, minus C2 F3. This is F3 and F3 is minus. So C3 and F3 square. This is plus C5 orthogonal F5 square d tau, and this will be minus and this will be minus C3, and minus this will be C6 F6 square and d tau is equal to 0. As this is normalized condition 1, 1, 1, 1, so from here we get relationship C2 minus C3 plus C5 minus C6 is equal to 0, or C2 minus C3 is equal to minus C5 plus C6. This is the relationship we got. And from earlier we derived that C1, C2, C3 is equal to 0. So here we can take that C2 plus C3 is equal to minus C1. So suppose this equation number is 7. This is equation number 7, and we add this C2 plus C3. C2 plus C3 is equal to minus 7, and we get C3 cancel 2C2. 2C2 is equal to minus C1 minus C5 plus C6. This is equation number 8. And minus C5 we can replace by C2. So C2 put that C2 is equal to C5 in equation 8. So we get that 2C2 plus C1 is equal to minus C5 plus C6, and if we put minus C2, this will be minus C2, so it will be 3C2 plus C1 is equal to C6. This we get relationship, and C6 is equal to C3. So this is another relationship, 3C2 plus C1 C3, and if we put this 3C2 from here we can get relationship that C2 plus C3 is equal to 0, is equal to minus C1, and C2 plus C1 is equal to minus C3, and 3C2 plus C1 is equal to C3. On adding we get this 4C2 plus 2C1 is equal to 0. Therefore C1 is equal to minus half C2. This C2 we got in terms of C1. Now all coefficients we will try to get in terms of C1. So we have already got C1 is equal to C2. This is C1 is equal to minus half C2. C5 is already C4 is already in terms of C1, and C5 is equal to C1. So C1 is equal to, we know that C2 is equal to C5 and C2 is equal to my C2 barabar C5. So C5 is also minus half C5 is equal to minus half C2. So C5 is also thus we can write down that minus half C2 is in terms of C1, C4 is in terms of C1, and again C5 is also minus half C1 because C2 and C5 is equal to minus half C1, and now C3. C3 we calculated that C3 is equal to C6, and we can have this C6 is equal to C3, and for C6 we can take C1 plus C2 plus C6 is equal to 0, and C1 minus half C1 plus C6 is equal to 0. Therefore, C6 is equal to minus half C1. So, therefore, C3 is also minus half C1 and C6 is equal to minus half C1. So now we had got all the coefficients for phi 5. Therefore, phi 5 is equal to C1 minus half C2 minus half C1 minus half first I write down that phi 5 is equal to C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 F6. Then C1 F1 plus minus half C1 F2 minus half C3 F3 minus C1 F3 minus C1 F4 minus this will be minus half C1 F5 and this is plus C6 I should calculate again that C1 is C1, C2 is minus half C1, half C1. So C6 is equal to half C1, and so C3 will also be half C1. This is half C1 is equal to C6, no, this is minus half C1. C6 is equal to minus half C1. So minus half C1F5 minus half C1F6 is equal to C4, so it is plus. Knew that C1 is equal to C4. C4 is in terms of, so it is C1 is plus C1 4. So phi 5 is equal to C1 F1 minus half F2 minus half F3 plus F4 plus F4 minus half F5 minus half F6, and this is the expression for phi 5. This is the expression for phi 5. Now we apply the condition of normalization. Then we know that C1 square plus C2 square plus C4 square plus C5 square plus C6 square is equal to 1. So C1 square is C1 square plus C2 square is minus half plus 1 by 4 C1 square plus C1 square plus 1 by 4 C5 square plus 1 by 4 C6 square is equal to 1. C1, C1, 2, 1, 4, 1, 4. C1 square, C4 square, C3 square is also C3 square plus C3 square plus C4 square plus C5 square plus C6 square is equal to 1. So C1 square plus 1 by 4 C1 square plus 1 by 4 C1 square for C3. So 1 by 4 is 1 and 3 C1 square is equal to 1. Therefore C1 is equal to 1 by root 3. Here we get 1 by root 3. Phi 5 is 1 by root 3 F1 minus half F2 minus half F3 plus F4 minus half F5 minus half F6. So this is with value of coefficient, and so this is all about molecular orbitals and then expressions for molecular orbitals. Last molecular orbital, that is antibonding orbital, and that is phi 6 alpha plus alpha minus 2 beta alpha minus 2 beta anti-bonding orbital, anti-bonding orbital, L, and for x barabar 2, for x barabar 2 to find phi 6 molecular orbital. So for this again we write that circular equations, and these circular equations are as earlier that x C1 plus C2 plus C6 बराबर 0, C1 plus x C2 plus C3 बराबर 0 and this C2 plus XC3 plus C4 is equal to 0. This is equation number 1, this is equation 2, this is 3 and C3 plus C3 plus XC4 plus C5 is equal to 0. This is 4 and C4 plus XC5 plus C6 is equal to 0. This is equation number 5 and C1 plus C5 plus XCX is equal to 6. This is equation number 6. These are the secular equations we get after solving two matrix. Then now subtract. Now subtract equation 3 from equation 2. Then we write C1. Definitely here it is x barabar 2. So this x will be replaced by plus 2. So 2C1, 2C2 and 2C3, 2C4, 2C5 and 2C6 because x is equal to 2. So we have replaced 2 by x by 2. Then subtract equation 3 from 2. Then what we get 2 is C1 plus 2C2 plus C3 is equal to 0. Then I will subtract here minus C2 plus 2C3 plus C4 is equal to 0. Then C1 plus 2C2 plus C3 minus C2 minus 2C3 minus C4 is equal to 0. Then C1 plus C2 minus C3 and minus C4 is equal to 0. Let this equation is number 7. Now subtract equation 4 from equation 3. Equation 3. 4 from equation 3. What we get? C2 plus 2C3 plus C4 minus C3 plus 2C4 plus C5 is equal to 0, and C2 plus 2C3 plus C4 minus C3 minus 2C4 minus C5 is equal to 0. This is phi 6, this is phi 6 and anti-bonding orbital. Now subtract, say this equation is 8. Say this is equation number 8. Subtract equation 8 from 7, then we get C1 plus C2 minus C3 minus C4 minus C2 plus 2C3 plus C4 minus 2C4 C2 plus C1 plus C2 plus C2 minus C2 plus 2C3 plus C4 minus C3 minus C3. I have not completed this. C2, here we get C2, 2C3 minus C3 plus C3, C4 minus C4 minus C4 minus C5 is equal to 0. Then we write down C2, 2C3, C3, C3. So C2 plus C3 minus C4 minus C5 is equal to 0. C1 plus C2 minus C3 minus C4 minus C2 minus C3 plus C4 plus C5 is equal to 0. Therefore, C2 will be cancelled and C4 will be cancelled. Then here we get that and C1, where is C1 minus C3, C1 minus 2C3 plus C5 is equal to 0, or we can say that C1 plus C5 is equal to 2C3. This relationship we got. Now keep this relationship in equation number C5 1 5 C3, C1 plus C5 plus C5 is equal to 2C3 in equation 6. Then equation 6 is C1 plus C5 plus 2C6 is equal to 0. So here we write that C1 2C3 plus 2C6 is equal to 0. Therefore, C6 is equal to minus C3. It implies that C6 is equal to minus C3. Even relationship we got this. Put यहाँ से फिर put C6 is equal to minus C3 in equation 1. Then we get 2 C1 plus C2 minus C3 is equal to 0. This is equation number 9. Now add equation 2 and 9. 2 and 9. So we get C1 plus 2C2 plus C3 plus 2C1 plus C2 minus C3 is equal to 0. C3 and C3 cancel, therefore we get 3C1 is equal to 3C2, therefore C1 बराबर C2, or you can say 3C1 plus 3C2, 3C1 plus 3C2 is equal to 0, therefore C1 is equal to minus C2. Therefore C1 C2 is equal to minus C1. So we have taken C2 in terms of minus 1. Now and C6 we have got two relationships, that C2 is minus C1 and C6 is minus C3. Put values, put C6 बराबर minus C3 and C2 बराबर minus C1 in equation 1. Equation 1 is 2C1 plus C2 plus C6 is equal to 0 and C6 is equal to minus C3. So we get 2C1 minus C2 is equal to minus C1 plus C6 is equal to 0. Therefore C6 is equal to minus C1. This is another relationship which we have got in terms of C1. So C6 बराबर माइनस C6 बराबर माइनस C6 बराबर माइनस C1. Therefore C3 is equal to C1. C6 is equal to minus C1 and C6 is equal to minus C3, therefore C3 is equal to C1. Now put values of C2, C3 in equation 4. Equation 4 or C3 we have got, C2 we have got, then we C2 plus 2C3 plus C4 is equal to 0. C2 this is not in terms of minus 1, so we have got C5. We can keep the put the values of C6 and C1, C5, C6. We don't know the value of C5. Yes, C1 and plus C5 and plus 2C6 is equal to 0. This is equation number 6. तो यहाँ पे लिख सकते हैं put C6 बराबर minus C1 in equation 6. Then you get C1 प्लस C5 प्लस C6 बराबर है माइनस C1, C6 बराबर है माइनस C1, तो माइनस 2C1 is equal to 0, therefore minus C1 is equal to minus C5, therefore C1 is equal to C5. This is we got in terms of C5 is equal to C1. Now we take for C4. C5 बराबर C1. Now put C3 and C3 and C5 will be in C4. Then put C3 बराबर C1 and C5 बराबर C1 in equation 4. Then we get C3 plus 2C4 plus C5 is equal to 0. C3 is equal to C1. C3 is equal to C1 plus 2C4 and C5 is also C1 is equal to 0. Then 2C1 plus 2C4 is equal to 0. Therefore C1 is equal to minus C4. Here we got C4 is equal to minus C1. Now we know that atomic orbital, apply the normalization condition, that phi 6 is equal to C1 F1 plus C2 F2 plus C3 F3 plus C4 F4 plus C5 F5 plus C6 F6. Then in terms of C1 F1 minus C1 F2 plus C3 C1 F3 minus C4 F4 plus C1 minus C1 F4 C1 F5 minus C1 F6. So we get that C1 F1 minus F2 plus F3 minus F4 plus F5 and minus F6. This is phi 6. And now apply normalization condition. Apply normalization condition that C1 square plus C2 square plus C3 square plus C4 square plus C5 square plus C6 square is equal to 1. That values C1, C6 is minus C1 and C4 is minus C1, C2 is minus C1. So in square they will all be positive. So this is C1 square plus 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 C1 square is equal to 1. Therefore 6 C1 square is equal to 1. This implies that C1 square is equal to 1 by 6, implies that C1 is equal to 1 by root 6. here we got the value of C1 and we will put here that phi 6 is equal to 1 by root 6 F1 minus F2 plus F3 minus F4 plus F5 minus F6, and this is phi 6. So this is all about anti-bonding orbital. Thank you.